Hello everyone, this is Rajavi Janjarla. I'm an educator at Unacademy. You can follow me on Unacademy Learning app where you can find my other courses as well. In this lecture, we are going to solve an example problem which is based on the concepts of the probability of survival of rolling contact bearings. And please rate, review and share the video and also subscribe to Unacademy YouTube channel. In the last lecture, we have found the relation between the relating life of the bearings and also the life of the bearings which has the reliability more than 90%, right? So with the help of those concepts, we are going to solve an example problem on the bearing probability of survival. Here we have the example problem. A single row deep groove ball bearing is subjected to a radial force of 8 kilonewtons and a thrust force of 3 kilonewtons, right? And the value of x and y factors are 0.56 and 1.5 respectively. The shaft rotates at 1200 rpm and the diameter of the shaft is 75 millimeters and the bearing with C dynamic load capacity of 1,12,000 newtons is selected for this applications. Okay, so here they gave the value of the two different components of the force acting on the bearing, right? So we have to find the equivalent load acting on the ball bearing with the help of the relations for the equivalent load for the static loading. Okay, so they have given the dynamic load carrying capacity also. So we have to calculate or estimate the life of this bearing with 90% reliability, which means the value of L10, which is corresponding to the 90% reliability of the ball bearings in a test group. And we have to estimate the reliability for 20,000 hours life. So here also the value of the life is given in hours, working hours. So we have to convert it into the value in million revolutions so that we can get the value of the dynamic load carrying capacity relation. So here we have the solution. So the formulas required in this example problem will be the value of the equivalent dynamic load given by P equals to XV FR plus by FA. And the bearing life in million revolution is L10 equals to C by P to the power of P. Here we have to use the value of P equals to 3 because here we are using the deep groove ball bearing. So for all ball bearings we have to use the value of P equals to 3, right? That's why we have used here also 3. And the bearing life in working hours is given by L10 equals to 60 into N into L10H by 10 to the power of 6. This is the relation between the life in million revolutions and also the life in working hours. Here the value is given in working hours. That's why we need a relation to find the value of L, the life of the bearing in million revolutions. Okay, and the reliability other than 90%, we have found the value of the relation between life which is corresponding to the reliability more than 90% and the rating life given by L by L10 equals to log E 1 by R by log E 1 by R 90 to the power of 1 by B. Okay, so with all these formulas we are going to solve this problem. So bearing life with 90% reliability. The bearing life which is corresponding to 90% reliability is L10, right? So in the problem they have given FR equals to 8 kilonewtons, which is the radial load, and Fn is equal to 3 kilonewtons, which is the thrust load, and x equal to 0.56 and y equal to 1.5, and n, the number of revolutions, is given by 1200 rpm, and they have given the value of T, the diameter of shaft is 75 millimeters, and the value of the dynamic load carrying capacity is 1,12,000 newtons, right? So bearing life with 90% reliability, we need to find the dynamic equivalent load given by P equals to XV FR plus Y into FA, where FR and FA are given in the problem and X and Y also given in the problem. So on substituting these values in this equation, we can get the equivalent dynamic load. Okay, so with the help of this value, we can find the value. We can substitute this value in the formula for the dynamic load carrying capacity. Okay, so that's why we have calculating the equivalent load. So for any comparison, for any life calculations, we have to first find the equivalent load. For the cyclic loads also we have to find the equivalent load, and for the static loads also we have to find the equivalent load. Here we have found the equivalent load 8,980 newtons. Okay, the life of bearing in million revolutions with 90% reliability is given as L10. So we have to find L10, right? So it is given by L10 equals to C by P to the power of 3. So they give the dynamic load carrying capacity C on lakh 12,000, and we have found the value of P 8,980, and substituting these two values we have the value of L10 in million revolutions given by 1940.1 million revolutions. So we can find this value in working hours with the help of the relation between the rating, this life in working hours, and the life in the million revolutions is given by this formula. L10 equals to 60 n into L10h by 10 to the power of 6. Okay, and on substituting these values in this relation, we can get the value of life in working hours given by 26,945.83 hours. So this is the value of the life in working hours. Okay, so next we have to find the reliability of for 20,000 hours life. So as you expect from this 20,000 hours of life, the reliability is more than 90%, right? So for this we have to use the relation between the rating life of the ball bearings and also the life of the ball bearings which has the reliability other than 90%. Okay, so we can use the relation from the Weibull distribution given by L by L10 equals to log E 1 by R by log E 1 by R90, which is the reliability for 90%, and it is corresponding to L10, the rating life, to the power of 1 by P. Okay, so on rearranging we have L by L10 to the power of P equals to log E 1 by R by log E 1 by R90. Okay, so on substituting the value of L, the life given, and L10, the rating life that we have got in the last slide, and the value of R90, that is 0.9, right? And B given value we have 1.17. We get 20,000 by 26,945.83 1.17 equals to log E 1 by R by log E 1 by 0.90. So on solving for R, the reliability which is corresponding to 20,000 hours of life given by R equals to 0.9283 or 92.83%. Okay, so this is the process to find the reliability of the bearings which has more the life, or the life which could have the reliability more than 90%. Okay, so this is for this example we have found R equals to 92.83%, which is more than 90%. So it has the value of more than 90%, right? This is very useful bearing, and because it has the reliability more than 90%, which will be given in the manufacturer catalog, right? So it has the value greater than that value. Thank you.